Right now, there is a chaotic storm of digital signals happening inside your computer. In the next 6 minutes, our goal is to cut through that noise, seize control, and force the machine to execute a single, precise command. Software engineering can look intimidating from the outside, but at its core, programming is simply the act of giving incredibly specific instructions. The friction comes from how we communicate. Humans speak in flexible languages full of context. Your hardware, though, strictly processes raw, numerical binary. It only understands ones and zeros. This diagram shows how we bridge that gap. Python is our critical intermediary, a translator taking simple human logic and converting it directly into machine-readable data. Format your initial instruction correctly, and Python handles the complex translation completely autonomously. Mastering Python simply means learning how to clearly format your intent so this translator understands exactly what you want. To start formatting that intent, we need a clean workspace. This is a code editor. It provides a controlled environment where we can draft our commands without background interference. Step 1 is creating a new file. But a blank file is useless unless the computer knows what it's for. We have to append a specific suffix to the file name to dictate its purpose. We use the .py extension. Typing .py at the end of your file name acts as a universal flag. It forces the computer to interpret everything inside that document through the Python translator. Without that exact extension, the machine treats your document as plain text. With it, your text becomes executable logic. Now that we have our live workspace, our immediate tactical objective is to force the machine to display a customized message back to us on the screen. We start with the action word print in lowercase. Next, we attach parentheses, acting as a mechanical container. Finally, we place "Hello World" inside, enclosed in double quotes. This classifies it as raw text, ensuring the computer doesn't process it as a command. Once these 3 components are assembled, you have a complete functional instruction that the machine can process instantly. What we just wrote follows a specific set of rules known as syntax. Syntax is the rigid grammar the translator requires to process your instructions without crashing. This schematic breaks down our syntax. The first block, print, is the function dictating the operation. Parentheses act as the delivery vehicle, holding target data. Finally, quotation marks wrap the text, acting as a safety barrier so the machine won't calculate the words inside. Every piece of punctuation in this line creates a specific boundary that allows you to control exactly how the computer reads your intent. Now that the syntax is correct, we need to trigger the execution. In most editors, you simply click the Run button at the top of the screen. Watch the terminal area below. When we run the code, our translated instruction provides immediate output. The phrase "Hello World" printed in clean white text. The terminal shows exactly what was requested, confirming the translator processed the syntax without error. When syntax rules are broken, the translator halts the process to prevent system errors and generates an error message instead. First failure point, violating case sensitivity. Capitalizing the P in print triggers a red error line. The machine rejects the unknown command. Second failure point, stripping away protective quotation marks. Without them, the machine misinterprets "Hello World" as a command, causing an immediate syntax error. Errors are simply the machine's requirement for perfect grammar. They provide the feedback needed to fix the instruction. To organize these syntax rules, we use a simple mnemonic protocol, PPQ. First, P for the print command. Second, P for the parentheses, your data vehicle. Finally, Q for quotes. This completes the visual checklist for the required punctuation. Now it's your turn. Open a new file, type out the PPQ sequence, but replace "Hello World" with your own custom message. Then hit Run. By executing that code, you've transitioned from a passive consumer of software to an active architect of logic. Secure these new skills through repetition. Hit subscribe, and let's keep building.